Today, I'll be talking about water. Water, something that most people take for granted and use on a daily basis. Whether it's getting up in the morning, taking a shower, brushing your teeth, or water sports like swimming, surfing, kayaking, and even drinking water. And it's that last one, drinking water, that is a particularly limited resource fraught with diverse challenges requiring equally diverse solutions. Little did I know growing up in the Monterey area about all of these issues around drinking water and that I would get involved in the complex world of water. Growing up in Monterey, I heard occasionally about a drought. I saw conservation cartoons in the local newspaper talking about using drip irrigation or other measures, but I really wasn't aware of the water issue that surrounded me. When I turned on the faucet, water came out. When I looked around the landscape, it looked relatively green. So it wasn't something I thought about regularly. Then for college, I moved to San Diego, and there, with a more arid climate, almost desert-like, it made me start to think, why were people able to have these green lawns in front of their houses when there was such a dry climate around them? And eventually I learned that they were importing water, bringing water in from the north via the Colorado River. And I knew that Monterey did not have that additional resource of water at another location. And then after college, I moved to Guinea, West Africa. There, the capital, Conakry, is one of the 10 wettest capitals in the world. And you see water just flowing on a heavy rain, water flowing down from a roof, flooding streets. It seemed like an abundant resource, which would be great if you look at California. But there they had their own challenges. In terms of most people's drinking water came from untreated well water. And myself, like many Ghanaians, I got waterborne diseases while I was there, like Giardia. Fortunately for me, I was able to fully recover and eventually head back to the Monterey area. But back in Monterey, now when I turned on the tap, I started to think more about it. I started to appreciate that clean, safe drinking water that seemed to effortlessly come from the faucet in my kitchen. But as an engineer, I started to question it and say, okay, where is this water coming from? How does this work? And what I learned was that for most of the source water on the peninsula, it comes from underground water in aquifers and basins that have rainwater or river water that percolates down into those basins and aquifers. And to get that water out, there's wells that pump that water out from underground. And they transfer that water to a treatment system, usually treatment plants that have chemical disinfection to be able to keep the water clean. They might have things like sand filters and other equipment or components for the treatment process to have clean, safe drinking water. From there, most of the time it's boosted up through pumps to large storage tanks on the top of hills. And that water can store the water and be ready to supply the community as needed. When the need is there, the water flows down through mains with gravity flowing, creating pressure in that main to be able to go through the meter in front of your house at the right pressure needed for all the water fixtures in the houses, whether that's the shower or the faucet, everything needed to be able to have that water flow out. And when you look at all this different infrastructure to be able to treat and convey that water, it seems great, especially compared with places like West Africa. But even in the US, there's challenges. In terms of the source water for rural areas where there may be, old septic tanks or additional agriculture challenges, you can have nitrogen and phosphorus that can leak down into the source water underground. For the treatment plant, if you have certain treatment processes, they can react with lead and copper and piping and have a Flint, Michigan type issue. Booster stations, those that pump up to big storage tanks, can have power outages, and if you don't have a generator there, that water in a storage tank won't be filled that may be needed during a fire at a fire hydrant. And even the storage tanks themselves, if there's an earthquake, there can be damage. Mains going down to homes can break and lose pressure. So there's a lot of different things throughout the US that can have challenges with water systems. And those are only a couple of the reasons why the American Society of Civil Engineers for the US as a whole gave relatively low ratings for the water industry. But these issues that I mentioned for typical US water utilities is really not the main issues for Monterey. The main issue for Monterey, the number one issue is source water, balancing, having enough source water to meet the needs of the community. And to be able to understand that need to balance source water with community needs, you really have to go back to the 1880s when we started to have some of the basic infrastructure that we have today in our system. It started then with a relatively small population of around 1,500 that was reliant on cisterns, wells, streams. And developers from the Bay Area looked at this beautiful location in Monterey Peninsula and said, you know, this could be a world-class tourist destination. They wanted to build a big hotel, the old Del Monte Hotel. And they looked at the water around there for wells. The water quality wasn't what they needed. So they built a dam along the Carmel River and transferred that water all the way over to their hotel they were building, which is now the Naval Postgraduate School, adjacent to Santa Catalina School. And that Carmel River source water was the majority of source water relied on. A little later, the Seaside Basin area adjacent underground basin water was found a little deep with deeper wells. And that historically became the two main sources of water, with Carmel River being 3/4, Seaside Basin 1/4. Fast forward to today, and those 1,500 population, after you get Cannery Row with increased, commercial fishing, you get tourism, you get population growth, and now you have 100,000 people approximately served a century later. But a century after the 1880s, you didn't really have much more source water to provide to those people. So you had, your limited source water, but increased demand. And what that meant was for the Carmel River, you have habitat along it, like red-legged frog that need ponds for their eggs and tadpoles, steelhead that need, the river to be flowing to migrate up through to spawn and then go back out to the ocean. And things were being done, like in around 2015, San Clemente Dam was removed because of structural issues that helped with the steelhead migration also. But, that didn't address the source water issue. And even in the Seaside Basin with pumping to meet community needs, you can see groundwater, the groundwater levels underground start to go down and the ocean level doesn't change. So you have the risk of potentially the ocean water starting to migrate inland for saltwater intrusion. So you have a lot of concerns, environmental concerns, with pumping these limited resources to keep meeting increased demand of population. And what the regulators did is they came in and they said, okay, well, we gotta reduce the pumping. The State Water Resources Control Board issued a cease and desist order on the Carmel River to reduce that pumping. The Water Master adjudication to ramp down pumping in the Seaside Basin also. And you can see on these graphs, over the last decade and moving forward a couple of years, you have over half reduction in pumping from these historic sources, which helps the environment. But at the same time, when somebody in the community turns on their tap, they still expect water to come out. So where do you get that new source water if your historic main sources are being reduced? So brainstorming was going on, with these new orders and regulations, and every idea was brought up, from icebergs being shipped in the fresh water to, fog collection systems locally. And the amount of options that were there was relatively limited to a couple ideas. Ultimately, you had, your Carmel River and your Seaside Basin, but that was the historic. But then moving forward, starting in the early 2000s, the first real project to gain traction for new source water was the Aquifer Storage and Recovery Program. So what this is if there's a heavy rain there, like there was in December of this year, and the river fills up and it breaches the Carmel Lagoon, and that fresh river water flows out to mix with salt water in the ocean. Well, if it's a lot of rain, it's more than the steelhead and the red-legged frog need. So we can ramp up our wells or pumping along the Carmel River, and that excess water that's not needed to meet the daily community needs, we can put that over the hill like that yellow arrow and inject that into the Seaside Basin to later use during summer months when we want to limit pumping off the Carmel River. So this is a rain collection system related to, maximizing sources of Carmel River and Seaside Basin. Next up is about a decade later, we had desalting was an option that was implemented with Sand City putting into service a desalination plant. And what that involved was vertical intake wells along the beach that pulled in brackish water, a mix of fresh and salt water, and then transferring that to a desalination plant that has energy recovery devices to stay energy efficient, and using that water to be able to distribute to the community. And it's from a source that's not rain dependent. The ocean, it's there, it's sustainable. So that was a second source that was brought in. And then a decade after that, approximately just recently, Pure Water Monterey, a recycle reuse project, was implemented. So this is taking, stormwater, wastewater, ag runoff water, and treating that to advanced standards, transferring that again to the basin, injecting that in, and later pulling that out as potable treated water. So we have really 3 recent water supply projects that relate to rain collection, desalting, and reuse of water. So those are projects that have gone on in the not too distant past. And you can see here, that historic source is Carmel River with 3/4, Seaside Basin with 1/4. Now our current source is a much more diverse portfolio, with Carmel River being reduced, Seaside Basin being reduced, and the new supplies being added to the portfolio. However, we still need to look to the future. We need more supplies to meet community demand. We are looking to augment all of these: the rain collection, the recycle, reuse, and the desalting of water are all important resource projects to be able to meet those water needs. But just looking at the source water is really only one half of the equation. The other part that you need to look at is water footprint, or how much person or community or location is using, and what conservation measures can be done. So the first part you can look at is reduction of indoor and outdoor water use. For outdoor, it can be, at my house, I have drip irrigation, I have artificial turf, I have rain collection barrels, and I know SantaCatalinaSchool has, water collection tanks and artificial turf lawns and drip irrigation. So they're doing all those measures too. For indoors, water efficient fixtures, whether for your shower, your faucet, those kind of aspects, and others are critical. And that's something that can be done at a personal level, which is great. Another thing that can be done at a personal level is change in diet. Just looking at when you go to a restaurant or you go to a grocery store, what are you buying? For instance, meat. If that's meat that's not pasture grazed cows or grass-fed meat, there's a good chance that, that's feed that was irrigated and brought in, and then the processing with the meat also. Just a hamburger can require 600 gallons or more to be able to have that meat for the hamburger. So thinking about limiting the amount of meat, or being conscious of the type of meat that you eat, making sure that's grass-fed or pasture raised is important. And then also other types like processed foods, heavily processed, require more water. For spaghetti sauce in a can that you buy from a store requires a lot of water. If you have a tomato plant growing that you can pick tomatoes and make the sauce yourself, I mean, there's nutritional value there, but there's also water conservation too. And then finally, the last part to this three-legged approach is recycle and reuse. That can be kind of our standard recycling with, paper or plastic. That process requires less water than starting over with a new, completely new, say, plastic bottle or paper. And then the reuse side could be related to, say, jeans, for instance. Jeans typically use over 2,000 gallons to be able to produce those jeans. So thinking about, if you do get jeans, making sure you take care of those jeans, you make them last longer, and then when you're done with those jeans, if they still look okay, giving them to a thrift store so somebody else can use them, or ideally, buying your new jeans at those thrift store, or your next pair of jeans at the thrift store. So really being conscious of what you're purchasing and how you're treating it. So ultimately what you have is these 2 different items to balance. You have the source water and you have the water footprint. And if you do nothing, unfortunately, what happens with the source water is with climate change, drought, increased restrictions, that just starts to go down in terms of availability. And then water footprint, population growth, consumer needs, that goes up. So this imbalance on its own occurs more and more. So we have to be proactive to be able to get that to balance out, whether we're looking at next generation new sources of water, or augmenting existing sources that we have, pushing that forward. And I really challenge you as the next generation to come up with disruptive ideas for this. It may not apply to the Monterey Peninsula, but it could apply to, a country across the world, because there's diverse challenges all over this world. And something you can do right now at a personal level, everyone can do, is think about their water footprint. Think about, what you're doing around your home, or what you're purchasing at a restaurant or at a store, and trying to balance that need with availability of source water. So and that can help at a global scale, not just locally too. So I know this problem is older than all of us, and it's fraught with challenges, but there are collaborative ideas that can be had. There's new solutions that can be had, and I challenge everybody to just keep moving forward, keep coming up with great ideas, and looking to not just solve the problem for right now, but also for the next generation to come. Thank you.